Welcome for the session 2, module 2, product design. Subject product life cycle management, 8 semesters, mechanical engineering. As of this course content is well already is known. That is what's all the course objective and course outcome. Where previous sessions only were discussed, and as comes to the outline of this chapter is also discussed. In previous sessions, we had just discussed about what is the introductory concept of product design and organization and decomposition, product design process, as well as engineering design. And then in this particular chapter, we are going to particular session, we are going to discuss about methodological evolution in product design. Okay, as of now, this particular concept, methodol methodological evolution in product design. So we need to understand how the evolution of this product design it is occurred. Why? Because everyone is need to know how the product design is evaluated through the particular sessions. So we need to enhance our knowledge of product design, how it is concerned with this particular topics. Okay, this methodological evolution is very important that as that traditional product design and development process involved as well as structured sequential step-by-step process is involved, with each step required to complete before the subsequent steps as this cloud has begin. We need to understand how these traditional products are designed and development as process involved as well as structured. This subsequent sequentially it's step by step process only, with each step required to complete the before and subsequent steps are could begin. For example, the production, assembly and packing departments start functioning only after the designing is completed. The various issues concerned with these departments are not defined and addressed and left for the related department to solve. These are all very important. Means how this um, evolution is occurred means everything is important as this methodological evolution of particular product design, and many product designs are not defined and addressed and left the related department to solve. So many product design changes as initiated during this stage. We need to understand why these particular products designs are not defined and addressed, left out related to the department to solve. What are the problem which is related to particular department, that should be their own concern only, they are need to solve. Many product design change in initially initiated during these stages only. And then as coming to this, the increased complexity and challenges in designing product and production system due to more changeable and customer demands, frequently product updates and the plans for sequential structure of this design and development process. So we need to understand how this methodological evolution, which is stage by stage studies of this product design, is being concerned. As coming to this, there are some few advantages and disadvantages is also there in this particular products. And here product design, so we have some disadvantages regarding the methodological evaluation. As of two disadvantages is concerned, prolonged development time due to sequential nature of this different function is the one of the disadvantages, and limited capacity for production improvement, product improvement, because the poor communication between the various functions and consequently reduces and fragmently information flow. So these are all two different disadvantages for the methodological evolution in the product design. So somehow we need to understand these disadvantages also along with the advantages. We need to combine those, and then we need to obtain our extracting our own properties to that concerned, as the product design and evolution should give a good outcome. So, as coming to this methodological evolution in a product design, the rigid sequential structure in a traditional product design is thus supplemented by two new methodological contexts provided for a simultaneous and closing interactive design actions of analysis and synthesis of regarding all phases of the product development. The two approaches in this stage are concurrent engineering as well as design for X. These two different methods are involved in discussion, so that these two methods are eventually create a methodological evolution in a product design. For concurrent engineering, there is also another name, simultaneous or integrated or life cycle engineering. As for design for X is DFX, the short form is DFX. So just move on to this concurrent engineering. So, concurrent engineering is commonly known as the simultaneous engineering. Is methods of designing and developing a product in which different stage runs simultaneously or work at the same time, concurrently rather than the sequentially. So, concurrent engineering aims at full harmonization between the increase in the product quality and reducing development time and cost through the structuring a product development that involves a large design team conducting simultaneous and interconnected analysis between the synthesis action and the inner relation to the all phases of a development. So this is what the concurrent engineering which do. For example, Mm, for example, we need to understand that production engineer need not to wait until the design work is completed. Uh, Instead, they can work parallelly, suggesting the change for cost-effective and simpler production methods and step involved in a effective design and tolerance problem that catch after before any product is made through much easier and less expensive to fix the problem that found during the any assembly stages. These are all concerned with this production engineers only, and these problems are identified as this problem is concerned and solved as easily as possible. The design process there are by reducing the cost and time involved in a production development as of concern with this some figure also is there to understand this concurrent engineering. You just see this highlighting the concurrent engineering, the role of production process and planning or its influence on the decision of the product design is well concerned, and emphasizing that disciplinary dimension of the all design team engaged in the product development process, paying the greater attention greater attention to the customer demand and satisfaction. This is a very important concept in any concern. The thing we need to understand, uh, we need to understand this concurrent engineering at the point of this stage is we need to give a more attention for customer demand and satisfaction only. As concerning the considering the reduction of development time and of time of market as the factor of products success and competitiveness. This is also very important highlights of a concurrent engineering. As of now, uh, we need to understand the reason for concurrent engineering can be considered an evolution of this product development practice based on the criteria of efficiency only. It is it is what the can be it is what can be seen as summary of the best practice in the product development rather than the adoption of this radical new sets in ideas. So this concurrent engineering can be represented as a concept in this particular graph. You just see this cost impact of a decision, as this product decisions and product decision and management control, production optimization, as this concept development, design details, planning tool, manufacturing. This is time. Means this overall graph is plotted versus cost versus time. So as of now, this time increases, production optimization also increases. As of this now, the production concept, at the time of concept development, if you produce any product, this is called, cost of this product will be high. As of the optimized path is achieved, and then the production time it may be more, but the cost of this particular product is will be very less. As of now, we need to understand the characteristics of this concurrent engineering. Before that, you just see what is the importance of this concurrent engineering. And this is product design, process design, tool build, tray layout, and production maintenance as customer. This is what the wing, that is actually double acting wing, shop floor production and design activity. These are all parallelly do. Why? Because this production means, as of the drawing is concerned, that achievable thing is will be drawn. Otherwise, the design is not safe. Design is not produced. So these are all connected, interconnected. Whereas the production details has been given by designer only. Design activities are very important for this production activity also. As of this product geometry and material specification, the strain triangles and manufacturing feasibilities and problem solving, these are all very involved regarding this design activity. As of this initial feasibility, design activity, tooling geometry, measured strain and machine setting and feedbacks of customers, this is also very important as this concurrent engineering and overall process, which is can be divided into design and production activity. So it has significant way to achieve the product design, process and tool design. Everything is important as this concurrent engineering is concerned. As coming to the characteristics of concurrent engineering, we have some advantages. uh, Reducing the product design and development time, it is very important advantage of this concurrent engineering. Limits product redesign, thereby allowing the products to reach the customer in a less time at very less cost also. This is what very important, this providing the characteristics which is produced through very less cost and very less time, and it is easily reachable to the customer. So whenever we have this property, then which enhances the productivity through the every discover of a design related problems, which can be rectified soon, and rather than that later stages in the development processes. So these are all the advantages. And reduction in the time to market helps companies to gain an advantage over their competitors. Means whenever we are fighting for an product, that reduction in a time which is helps well the market to for company to gain their advantage. Means if you producing in more faster rate, means our competitor, whenever the competition is there, there is time is very important. And the facilities rapidly response to the fast and changing customer demand. Means whenever we need to consider customer replay, and then we need to understand that customer need, and then we need to rapidly respond for the for their demand, and then that will be the outcome of this concurrent engineering also, outcoming of concurrent engineering. This is very important perspective. Improve the product quality through the enhanced design and manufacturing processes. So whenever the concurrent engineering, which is always helps to improve the product quality through the enhanced design and manufacturing processes. Facilitate the teamwork, means which is concerned with the teamwork only, and it is improvise this overall activity of this production and design. As coming to the disadvantages, concurrent engineering having effective if all design activities are performed in a parallel manner, and the making and among the different groups are integrated, and then concept required effective collaboration and communication among the team member. This is what the disadvantage. Concurrent engineering is always an effective design matter. So it parallelly we need to discrete the process, and then we need to combine. Through this, some disadvantages is also there. That is what the statement is regarding, and requires effective computer system for a data transfer and organizational integration. That is was the important thing. Means the digital information has to be stored in a computer, then data transfer and organizational integration. That is what the discreting and combining is known as integration. And as coming to the minor mistake in any stage can be impact all stages, and teamwork with the help of this particular product that may goes wrong. If that thing happens, huge losses has to be occurred. So we need to take care of minor mistakes in every stage. That has to be monitored, and take a control over that particular process mistakes. And strategies for recovering at the end of the product life. Coming to this concept, it's also very important. As of now, I need to understand this product design as design strategies as concerned. We need to understand this product recovery is a major contribution for implementing the sustainable business practice that can be result in saving energy as well as possible emission and the cost relative to the process of producing the parts, and in the volume of different materials. And as coming to this, many companies which is involved and implement product recovery management or waste management programs to recover the product and are its component, thereby eliminating the waste and increasing their properties. Means whenever the recycling these particular products, that will always in conjunction with this particular systems. And we need to understand what are all the different strategy which is helps to recover the product life cycle. And then you just need to know what is the of the different techniques which is always we discussed from methodological evolution. That is another technique apart from the concurrent engineering is design for X, and the design design of central development model. So this particular thing is very important, design for X. It's a very new methodological approach in a product design where the design has the ability to strongly influence the product performance in every phase of the product life cycle. So it is very important concern as the design for X or a DFX is concerned. The word excellence must not be interpreted in terms of performance or quality and reliability or durability also alone. Instead of dissipated in terms of manufacturing, cost, assembly, as well as any other varying characteristics related to the product. For this reason, the term DFX is better of as this design for X, where X refers to the variable aspect of the design which is being in focused. As of for example, we need to understand the variable for X may be included design for manufacturability, that is DFM, and design for assembly, DFA, design of logistic, DFL, and so on. Means whatever the thing which is included for particular reason. So we need to understand that is what we are short terming. All these DFX techniques or tools having in a common the aim integrated that requirements of the technical area X is the conceptual design phase of the particular products. Wherever the design for X aims to include the earlier consideration of the desired issues in the product development and covering both the design goals and constraint, while design goals are target to meet the such as low cost, quality, efficiency, as well as this production activity, that is productivity also. And constraint on the other end, are issued, such as capability of manufacturing equipment and material market aspects, and the practices designed for X is an often familiarized as guidelines that tell how the designer should accomplish the product designs. As coming to the guidelines, they serve as the input, the design process in form of the set of constraint and the purpose and approach and corresponding method that may be helps to generate and apply the technical knowledge to control and improvise the overall design ex- and even that particular characteristics of a product. In some cases the guidelines provided unique information that increases the awareness of specific desirable design characteristics. The guidelines serve for this best efficient practices during the design stage, benefiting that subsequent or not adhere during this design stage. It can lead a certain changes during the later stages of this product development, which can be highly expensive, so causing the project delaying and cost overruns. These are also very important guidelines for design for X. As concerned with this first DFX type approaches originated from in 1980s, when the design for assembly DFA and DFM are introduced. Since the DFX has expanded in new application area, and in 90s, later 90s, the environment issues are gathered attentions. Currently, the FX concept aim to cover the entire product life cycle. This is what the very important thing is concerned. As of now, some there is some techniques. So we need to understand what are all the tools which is behind that DFX techniques. As we seeing this table, which is different techniques which is used as the tool, and what are all the sub descriptions which is concerned. In serial number one, design for manufacturability, that is DFM. DMF DFM is a principle that process beginning guidelines for a manufacturing part and simple process and with low cost. This is what DFM. Design for inspection, DFI. DFI is the principle that process design guidelines for producing the part with features that are easily inspect with the readily available measurement instrument, so that the measurement and uncertainty is considered in the tolerance that are applied. Means that particular X technique which is involved in a quality control and quality and inspection. This is what the DFI. And coming to design for assembly, that is DFA. DFA is a principle that process design guidelines for the producing the part that facilitate the easy assembly, reduces the assembly time and possibility of error. This is what DFA means. Well, assembling prospects are concerned, whereas the part to part facilitation, and that was the reducing assembly time is techniques, and everything is to be. And coming to design for robustness, that is quality. Design of component is directed at reducing the sensitivity of the product performance to uncontrollable distribution phenomena, machining error, and unforeseen operating condition, and guaranteeing the product quality. This is what the design for robustness of quality. Design for reliability, DFR. Design of component and systems are aimed at improving the reliability of the constructional unit. This is what DFR. Design for serviceability and maintenanceability. This description which is having is design oriented towards facilitating the service and maintenance, so to favor the repair and interventions were directed as including the possibilities of failure and phenomena. As this maintenance is concerned, that post maintenance and the pre maintenance processes are very important, as this design of serviceability is concerned. As this design for safety, DFS, the design oriented towards controlling the safety standard and prevention of the malfunction of any during production or production of part use. That is what design for safety. Design for product uh, retirement recovery. This is sub standard design directed at the planning of disposal and recovering strategies in at the end of this product useful life. This is what the table is concerned with, several, that is 8 different techniques which are described. So we need to understand this is very important as the examination point of view. We need to understand this the effects techniques which is already used in our engineering field. And difference between the traditional engineering design as well as modern design, um, that is modern design with dfx. The traditional design engineering as a several thing, that is consider functional requirement is in traditional engineering, as the design with the dfx consider the life cycle requirement. As this side, left side of this table, which is considering traditional engineering design, in right side of your table this is dfx, that is design with fx, and address the other the aspect of after designing phase. It's early it is possible iterative in nature, that is traditional engineering design is one time right, but as concerned with traditional, that is heavy usage of tool. As concerned with design with dfx, heavy usage of the system, that is computerization of this tool is very important here. Not in traditional method, heavy usage of tools is very important as this physical tool is concerned. As of this they are traditional engineering method, they are using cad tools. And in this design with dfx depends on knowledge based system. And as coming to traditional engineering, responsibility over design is more, as your this design with dfx, the responsibility over whole life cycle is very important. And coming to traditional engineering design, design solely based on user requirement, production service, etc. Have to adopt the designer work is important. In coming with design with dfx, integrated design with involvement of a cross functional term is very important. This is what the overall concern which is always connected with this particular design x and design for x. And sometimes these are all very important as this tool is concerned. Thank you for watching this session too. This is Chetan Case.